Hello, everyone. Thank you for attending today. Today we'll be discussing fenestration testing. We will be discussing today topics, industry resources, some field testing specifications, field testing methods, possible failures, corrections, retesting, and expectations after the corrections are made. So let's start off with what is fenestration testing, or fenestration itself. Fenestration basically refers to the design or arrangement of windows or other openings in the exterior face of a building. These are some examples of that. Lower right, storefront, curtain wall would be similar. The middle section, we have some operable windows, some fixed windows, doors, and on the left, we have skylights. Industry resources. FGIA, it's the Fenestration and Glazing Industry Alliance, formed January 1st, 2020. It's a combination of AMA, the American Architectural Manufacturers Association, and IGMA, which is the Insulating Glass Manufacturers Alliance. That is a group of suppliers and manufacturers that promote awareness about technological advancement in the field. FGIA holds courses, training, certifications for products, installers, manufacturers, testing labs, and individuals. They help with building code writing and standards, help spread knowledge and changes in the industry. They have a website, FGIA Online, for more information. If you're familiar with Windows at all, you'd be familiar with seeing this on any of the products. AMA, which is the American Architectural Manufacturers Association. This is the source of performance standards for fenestration products. They do product certification, educational programs, responsible for outlining the specifications and guidelines for testing of the products, which we use quite a bit. And they also certify products and testing labs. So if you've ever purchased a window for your home, for example, you might have seen a little gold or silver label on a window unit, and that basically, informs you that the window has been tested by, or certified through AMA. It's been independently tested, certified. It would have the rating on it, specification they used, and the largest size of that product it would have been tested. ASTM, previously known as the American Society for Testing Materials, became ASTM International in 2001. These are the specific standards or test methods in detail that are used to test the fenestration products in both the lab and in the field. If you're familiar with ASTM at all, you would know that there's basically an ASTM standard for almost anything. NAS, or the North American Fenestration Standard, basically a combination of multiple documents. This is a description of the different types of fenestration products, lists the performance requirements based on class, and specifications for laboratory testing only. Field testing specifications.
Bill?
Yes.
I'm going to interrupt you one moment. Your mic is starting to fade in and out.
Is that better?
Yes.
Okay. Sorry about that. Okay, the first one we're going to discuss is AMA 502, Voluntary Specification for Field Testing, Newly Installed Fenestration Products. So this applies to testing of all types of products within 6 months of install only. After 6 months, you'd have to use AMA 511. Excludes testing for curtain walls, slope glazing, and storefront systems. That would be AMA 503, which we'll discuss shortly. This lists the short form field testing specification, which architects and specifiers would utilize this document, insert it into their specifications, and just fill in the testing values for that specific window type. It also lists the appropriate ASTM methods that should be followed when testing for air leakage resistance, which is E783, and water penetration resistance, which is E1105. So let's take a look at this short form field testing specification. This is a glimpse of this directly out of the AMA 502 document. And what this is, it basically gives you the exact verbiage to put into a project specification. The specifier notes just help give a little description of what you would take into consideration when using this document. Let's take a look at items 3 and 4 out of that. So item 3, air leakage resistance tests shall be conducted at a uniform static pressure of blank PSF. Maximum allowable rate of air leakage shall not exceed blank CFM per square foot. So to fill this in properly, basically you have to go to look up the exact product that it is that you have and go into the MAPS document and find the rate for that product type and see what it was tested at. So the field test pressure itself, let's say it was tested at 1.57 PSF. In the laboratory test, you would put that here. The allowable rate of air leakage, it is allowed to leak 1.5 times more than the specified leakage that it would have been tested at. The water penetration resistance test at item number 4 would be conducted at, and now that value for the test pressure would be based on the specified rate. However, it is dropped, it reduced to 2/3 of that. The reason they do this is because they understood that this is a field test and they've reduced the pressures or allowed it to leak a little bit more than it normally would under field condition or under laboratory conditions. Laboratory conditions, meaning perfect examples of that unit. Obviously, in the field, they'll be a little less than that, a little less than perfect. So that's the reason why they allow the extra leakage or the reduction of pressure. Prior to testing, you should inspect each unit that you'll be testing in advance. You measure for plumb, level, square. You want to cycle the unit 5 times to ensure proper function. Basically, you're just going to open and close the unit, make sure that there's nothing funny going on with it, where it takes extra pressure at one point, or it's binding up, or the latch doesn't latch. If you find any condition that's defective, you shouldn't perform the test until it's been corrected. AMA 503. This is the voluntary specification for field testing of newly installed storefronts, curtain wall, and slope glazing systems. Again, this testing is we're testing a products listed above within 6 months of install. Also lists a short form field testing specification similar to AMA 502 and lists the appropriate ASTMs to be followed when testing for air leakage resistance and water penetration resistance, which is the same test method as AMA 502. The short form field testing specification, it's a little bit different than the one for AMA 502. Basically, you're just going to fill in the newly installed whatever it is that you want tested at this point, whether it's a storefront or a curtain wall. And then you should also list the specific area or location that should be tested. I mean, that would definitely make it a lot easier for the testing agencies to come up with a proposal or know exactly what they're getting into as far as testing. A lot of times that's not it's not explained in advance, so it does make it difficult down the line when it comes time to take the test. So let's move into the lower portion for items number 1, 2. So optional air leakage resistance test should be conducted at a uniform static pressure of blank PSF. Maximum allowable allowable rate of air leakage shall not exceed blank CFM. Again, the static test pressure is going to be based on the actual performance requirements of that unit. The maximum allowable air leakage rate would be, again, just like 502, 1.5 times the leakage rate that the unit would have been rated for. Water penetration tests, this rating, again, it's just like 502 in the respect that you would do a 2/3 reduction in test pressure. Also for this method, you would want to inspect the unit and measure it for plumb, level, and square. If anything's found to be defective or something's missing, again, you should not perform testing until corrections have been made. We'll get into the field testing methods now. First one is E783, which is a standard test method for field measurement of air leakage through installed exterior windows. So for AMA 502, we have an example here of a test that we performed on a window unit. So how this is done is basically you have an air chamber on the inside. You can see in the lower photograph, that's pulling negative air across the test film. And then we have a sheet of plastic on the exterior face. So you would take the reading with the plastic up, take the plastic down, take another reading, and the difference of the two readings gives you the leakage across the specimen. Now, the reason we do this is to remove extraneous air out of the situation, because we don't want to measure, we don't want to know the air leakage or include the air leakage of our test chamber, air leakage through portions of the wall. We just want to know the specific air leakage through that specimen alone. And that's how that's accomplished. So again, as I mentioned before, the overall air leakage is allowed to be 1.5 times the value as defined in the NAPS document. Let's give an example of that. So let's say the product has a designation of an AWPG 40. NAF's document would state that it was tested at a pressure of 6.27 psf with an allowable leakage rate of 0.1 CFM per square foot. So in accordance with FAMA 502, requires that the pressure would remain at 6.27, but it would increase the allowable leakage rate to 1.5 times the laboratory requirement. So you can see it would be 1.5 times the 0.1 CFM per square foot. So our allowable air leakage rate in the field would be 0.15 CFM per square foot. Okay, ASTM E783. This is for AMA 503. So same type of setup as performance with AMA 502. We have a negative air chamber on the inside of the specimen, and we have basically our tear sheet up on the exterior face of the test specimen. We would take an airflow reading with the tear sheet up, remove it, take another flow reading, and it would be the difference of the two readings would be the actual flow through the specimen itself based on area. So in this, the overall air leakage is allowed to be 1.5 times the value noted in the project specification. Similar to AMA 502. So if you picked up on the fact that this said optional air leakage test, the reason for that being sometimes for storefront and curtain wall, depending on size, it may not be feasible to take an air measurement test or a leakage reading on the specimen, especially when you try to segment out a portion of a larger area. So what happens when you try to do that, if in this photograph, if I tried to do maybe just the left two portions of this area alone, it would pull air sideways into the rest of this unit through the mullions. And there would be no good way to section that off to come up with an accurate air leakage reading through just those areas. It's really designed to be able to take air leakage reading on that entire opening. Now let's take a look at E1105, which is a standard test method for field determination of water penetration of installed exterior windows, skylights, doors, curtain walls by uniform or cyclic static air pressure difference. So for AMA 502, again, we have our negative air chamber installed on the inside and a spray rack set up on the exterior face like you see in the top photograph. There's two different test methods for AMA 502. One is procedure A, which is a uniform static air pressure difference, which is a 15-minute test. So you'd have 15 minutes of negative air pressure, and you would have simultaneously the spray rack would be running for 15 minutes. This applies to AW rated windows only. Then we have procedure B, which is the cyclic static air pressure difference. What that is 4 cycles of 5 minutes on and 1 minute off of pressure. So you run that 4 times. And they do this so that you have 5 minutes of pressure, and then the 1 minute off pressure would allow water to escape through weeps. So you have, the only thing that changes is the interior pressure in the negative air chamber would be 5 minutes of negative pressure, and then 1 minute you would turn the pressure off. And you would continue that cycle. On the exterior face, the spray rack would run the entire 24 minutes of the test without being shut off. Test pressure for this would be 2/3 the rated laboratory test pressure for the product designation in the NAS document. So if we give an example of that, let's say the product designation class for this unit would be AWPG60. NAS document states test pressure of 12 psf. So per IMA 502 would require the test pressure be reduced to 2/3 the specified rating. So 2/3 of 12 would be 8. That would be test pressure. And since this is an AW window, we know that the test will be run at procedure A for 15-minute static pressure, as opposed to the cyclic static. So what is an E1105 failure for IMA 502? IMA 502 defines a failure. There's 2 different types of failure. One would be the water penetration attributable to the fenestration product specimen. So that's the unit itself. The penetration of uncontrolled water beyond a plane, parallel to the innermost edges of the product, and it indisputably originates from the fenestration product. They also have water penetration attributable to the perimeter joint. That's the other type of failure. And that's uncontrolled water that indisputably originates at the joint. So in the image to the right, it's a cross section of a window unit installed into a wall. And you can see here, this would be our negative air chamber. And you have a spray rack attached to the outside face. Let's take a closer look. So innermost projection, or the inside face, would be that red line. So any water that would cross that red line from the unit itself would be an automatic failure. Perimeter joint leak, would be any water leakage that you would see either on the outside perimeter or underneath the unit itself. You can see in this image they have it looks like a sill in place here. For this type of testing, you wouldn't want that there. There should be no interior finishes installed on a unit or around a unit when you are doing these tests. Here we have a couple images of failures. On the left-hand side and the right-hand side, you can see we've circled in red. You can see the water spilling over the back side of the unit. That is crossing the innermost projection of that unit. Oddly enough, you can see there's water built up on the inside of the unit here. In both images, actually, until that water actually spills over the back side of the unit, that is not actually defined as a failure for AMA 502. Okay, E1105 for AMA 503. Again, we have an air chamber on the inside and spray rack on the outside. Procedure A is a test method that would be utilized, which is uniform static air pressure for 15 minutes. Test pressure itself, 2/3 the rated laboratory test pressure for the product designation and the project specification. So, what is a failure for AMA 503? It is any water that is not contained in an area with provisions to drain to the exterior, or the collection of more than half an ounce of water in the 15-minute test period on top of any interior horizontal framing member surface. Any water present shall not extend beyond a plane parallel to the glazing intersecting the innermost projection of the test specimen, not including interior trim and hardware. Again, you can see in the image to the right, the inside has the negative air chamber installed, and on the left side, on the exterior face, there is the spray nozzle setup. Again, this is similar in the fact that a break in the plane of the innermost projection, the red line shown, would be an automatic failure. Perimeter joint leak on the top sides or bottom would be a failure. And these blue lines on top of the horizontal planes would be a failure as long as it's more than half an ounce of water and the water collected does not have a path to move back to the exterior face. This would be a couple of images of some failures here. On the left side, you can see the water running down the glass, landing on the horizontal surface. More than half an ounce of water is collecting in that location. On the right-hand side, you can see a little dampness on the basically the air barrier around the perimeter of the window. And that is leaking in with no exterior way to evacuate. Here we have another AMA test method, 501.2, the quality assurance and diagnostic water leakage field check of installed storefronts, curtain walls, and slope glazing systems. This is a test method used to evaluate the joints in the systems intended to be permanently sealed or watertight. This is not something you would typically want to use on any type of window unit that would be operable. Basically consists of a single spray nozzle, as you can see in the photograph there. It is used to spray the joints at a rate of about 5 feet in 5 minutes, held a distance of 1 foot perpendicular from the unit, and gauge pressure between 30 to 35 psi. So, what is a description of a 501.2 failure? Basically, it's any uncontrolled water that appears on any normally exposed interior surface, not contained or drained back to the exterior, or that can cause damage to adjacent material surfaces. And the collection of water, as a side note, has to exceed a half an ounce. So we have an image of a failure here on the right-hand side. You can see the water had run down the vertical mullion and on the glass, and is sitting on the horizontal surface. A couple more images of failures here. Again, water running down on the left photograph, down the edge of the unit, landing on the horizontal surface. Water collection is more than half an ounce of water. Right photograph is water leakage that is damaging to any other surface. Obviously, that water has no way to go back to the exterior face. Corrections and retesting. So AMA 502 and 503 basically have the same verbiage with regards to the repairs and retesting. If any specimen fails testing, either the installer, manufacturer, or both may have the chance to investigate and correct the specimen prior to retesting. AMA 501.2, 502, and 503 all have the same verbiage in that any corrections that were made have to be noted and must be approved as a viable option by the architect and or the owner's representative. Meaning that if a correction is made, it can't just be something that the contractor just decided they were just going to start caulking things up until they found something that worked, and it has to be an approved correction that is accepted. So what are the expectations after the corrections are made? So approved corrections have to be retested. Once retested and passed, they now become part of a punch list. So specimens are selected at random to verify the same condition exists. If it does, then the documented repair that had passed the retest is required now on all specimens that are found that have this same condition. So essentially, it could become part of a punch list item where they have to go look at every unit that was installed to verify that that condition either does or does not exist, and then would have to be repaired in the same manner. It is possible that the architect or client's representative may request additional testing because of this on a larger percentage of units if failures persist. What are the expectations? Here, an example of a correction. So on the left-hand side, you can see that there's a little gap there where no sealant had been applied. During testing, water was pulled in through those small gaps, creating a failure. Contractor came back, they had approved correction, You can see on the right-hand side where they added the sealant to cover those gaps. That was retested and passed, and this is a project where they had forgotten that on every window unit in the building. Here's another example of a correction where they had window units installed into an opening where they butted up to a brick. You can see on the left-hand side where the contractor had not tooled the sealant into the mortar joint. You could actually look through and see into the building through those joints. On the right-hand side, they had to add a little bit of sealant at every single mortar joint and tool it in there better. Here we have a window unit. This is on the interior face on the left-hand side during testing. You can see in the circled area, there's a little bit of water splatter on the vinyl in the chamber. And what was happening here was water would run down the vertical trim component inside the unit, and as it fell and passed over this gap, the negative air pressure sucked it in to hit the chamber, and that was an automatic failure. So what was the repair? Because the unit was non-operable and would never have to function or open or close, they utilized sealant to seal up that gap and any other slight gaps or openings that may cause the same type of condition. By doing that, that stops air passage. So without the air movement, it doesn't pull water through. All right, hopefully everybody got a little something out of that. Learned a little bit about fenestration testing in the field.